Glad to meet you on BakoMaths today. And today's lesson, we'll be looking at how to prove the equation of a circle passing through the origin, where we are going to look at both the standard form of the equation of a circle passing through the origin and the general form of the equation of a circle passing through the origin. Having known this, let's stay tuned and get started. Now, before we move to how to derive the equation of a circle passing through the origin, it is very crucial for us to know the meaning of a circle. Now, when we talk of a circle, then we are talking about a set of points on a plane equidistant from a fixed point. The fixed point is called center, represented by C, and the equal distance, that is the equidistant, is called the radius. Now, practically, when we talk of a circle, then we are talking about a set of points, just like you can see here, of which they have a fixed point, and that fixed point is at equal distance from the set of points coming together. So it means that this point is at equal distance from where it is to the center, so we can beautifully join it. And when we join it, the distance from the center to the point indicated there is what we call the radius. Now, better still, where the center is to a point here, then we can see that the distance from the center to where this point is what we call the radius. That's the equal distance. It means that the center is at equal distance to every point we see here. So beautifully, when we join all these points, then we get the circle. A circle. Knowing where that every circle has a face point called the center. Now, if this is clear, now let's move straight to today's mission. Now, the equation of a circle. The equation of a circle has two forms, which are I, the standard form, and II, the general form. So you are going to look at these two things. Basically, the equation of a circle has two forms. We have the standard form and the general form. Now, let's look at the proof of the standard form of an equation of a circle passing through the origin. Just like we can see here, proof of the standard form of equation of a circle passing through the origin. Here, we have our Cartesian plane, and our Cartesian plane, we can see that there is a circle drawn in it. Now, beautifully, we can see that this circle has center of 0, 0. This means that this circle is passing through the origin. So we have to indicate here at the center, this is the center, and this center has its coordinates 0, 0, which means that this circle is passing through the origin. Good. Now, from the center to any points on the circle gives us the radius, that is the distance. Now, assuming there is a point P on this circle, so let's call this P, that's the point P on the circle. It has its coordinates x, y. Then we are saying that the distance from the center to where the point P is gives us the radius, that is r here. Now, we can beautifully join them and we can see that they are going to form a right-angled triangle, giving us a 90 degrees angle here, which means that if this side is the center and on our right-hand side is the x-axis, then the distance between the center and the x-axis is what gives us as x minus 0. If here is a point, that's the y-axis, and to this side is the center, then the distance between the y-axis and the center is what gives us y minus 0. Now we can equally apply the Pythagoras theorem in getting the equation of a circle passing through the origin. So here we write by applying Pythagoras theorem, that is we applying the Pythagoras theorem. I think there is breakages in the pen we are using. So by applying the Pythagoras theorem, great. Then we can see that there is a point P here, and then the center is named as C. So beautifully, you can also name this point here, this side, as M. Great. So by applying Pythagoras, like we said, that means that the square of the hypotenuse, that is the side PC. So let's write PC here, squared, is equal to the square of the other two sides. That is the side CM squared plus the side PM squared. Now, what is the side PC squared? The side PC squared is what we have here as R squared is equal to the side CM squared is what we have here as X minus 0 squared plus the side PM squared is what we have as Y minus 0 squared. So X minus 0 is definitely going to give us X, and Y minus 0 is going to give us Y. So here we have Y squared to be equal to X squared plus Y squared. So that is it. So whenever we are talking about the standard form of an equation of a circle passing through the origin, then we are talking about this formula. Then we are talking about R squared is equal to X squared plus Y squared. So in any question given to us, and the question demands that we should find the equation of a circle passing through the origin, then it's very simple as that, because at the origin, the center there, or the points there, is 0, 0. That's the coordinate there is 0, 0. So if we are getting 0, 0 at the center, then definitely what's going to left is the points on the circle, that is X squared and Y squared, giving us R squared. Whenever a question demands for us to find the standard form, we just have to write this formula: R squared is equal to X squared plus Y squared. And that's very perfect and simple. So this becomes the standard form of the equation of a circle passing through the origin. Now, having known this, let's move straight to the proof of the general form of equation of a circle passing through the origin. So at the general form of the equation of a circle passing through the origin, we are going to refer from what we learned, that is the proof of the general form of equation of a circle. Before we get to the proof of the general form of equation of a circle passing through the origin, we have to refer from the general form of equation of a circle, and that is giving us, that is the general form of equation of a circle. Let's write here general form of the equation of a circle, and we know that one is giving us X squared plus Y squared plus 2gx plus 2fy is plus c is equal to 0. And this is the general form of the equation of a circle. Now, if you are saying that this general form of the equation of a circle is now passing through the origin, then means that the coordinate at the center is 0, 0. So that means that at the center, that is x comma y is equal to 0, 0. So this becomes the coordinates of the circle at the center. At the center, the coordinate there is 0, 0. So we are just going to do substitution here. Now let's write by substitution. That is, we are substituting 0, 0 into the general form of the equation. Then we are going to have 0 squared plus 0 squared plus 2g multiplied by 0 plus 2f multiplied by 0 plus c is equal to 0. And we can see that 0 squared is 0 plus 0 squared is 0 plus 2g multiplied by 0 is 0 plus 2f multiplied by 0 is 0. So at this point, from 0 squared up to 2f, 0, we are all going to get 0. And what is left? C. Now c here is equal to 0. So it means that the general form of the equation of a circle passing through the origin has c to be equal to 0. So we have to substitute it back. Now we can go ahead and write our final formula. So therefore the general form, the pen is lagging. The general form of the equation of a circle passing through the origin is given as. So if you know that the general form of the equation of a circle passing through the origin has the c to be equal to 0, then means that we have x squared here plus y squared plus 2dx plus 2fy. Remember, if it's the general form of the equation of a circle, then it's going to be plus c. But we proved that if this general form of the equation of a circle is passing through the origin, then c is equal to 0. So here we are going to have plus 0 is equal to 0, which implies that our x squared plus y squared plus 2dx, so plus 2dx plus 2fy now is equal to 0. So this becomes the general form of the equation of a circle passing through the origin. And it's very simple as that. So we are going to end today's video here, and thank you for watching. Kindly like, comment, subscribe, and share. Remember that this is BakoMaths. We are thinking beyond infinity. See you in our next video.